The question we are solving now belongs to test series 3. It is of control system subject. In specific, it belongs to Nyquist analysis of control systems. As per the question, the open loop transfer function of a unity negative feedback control system is given as g of s is equal to g of s multiplied by h of s is equal to k into 1 plus s divided by 1 minus s. We need to find the Nyquist plot of the given control system. From the given transfer function g of s multiplied by h of s, we see that upon substituting s is equal to j omega, g of j omega multiplied by h of j omega is equal to k into 1 plus j omega divided by 1 minus j omega. So from this we can say that the magnitude of g of j omega multiplied by h of j omega is equal to k multiplied by square root of 1 plus omega square divided by square root of 1 plus omega square. This is because of the reason that 1 plus j omega has a magnitude of square root of 1 plus omega square and 1 minus j omega has a magnitude of square root of 1 plus omega square. This upon simplification becomes k. From this we see that abs of g of j omega h of j omega has a magnitude of k for every omega. It means that the Nyquist plot is a circle. Also, we can write the phase of g of j omega h of j omega as phase of 1 plus j omega minus phase of 1 minus j omega. This upon simplification becomes tan inverse omega minus tan inverse of minus omega. So upon substituting different values of omega, we see that for omega equal to 0, g of j omega multiplied by h of j omega is equal to k at a phase of 0 degrees. Similarly, at omega equal to 1, g of j omega multiplied by h of j omega is equal to k at a phase of pi by 2. And as omega tends to infinity, we can write that g of j omega multiplied by h of j omega is equal to k at a phase of 180 degrees. So from this we see that as omega is varied from 0 plus to infinity plus, the g of j omega h of j omega plot varies between k at a phase of 0 to k at a phase of 5. So upon plotting the same in the Nyquist plane, that is g of j omega h of j omega plane, omega equal to 0 plus corresponds to this point and omega equal to infinity plus corresponds to this point. And we also seen that the Nyquist plot is a circle because the magnitude is remaining constant at k. So this is the variation of the plot from omega equal to 0 plus to infinity plus. Similarly, as the omega is varied for the remaining values of omega, we see that the Nyquist plot varies as shown. So from this we can say that the Nyquist plot is a circle which is centered at origin and is of radius k as shown. Hence, the Nyquist plot of the control system corresponds to the option D. So the correct option is D.